So, scientific notation should be towards the bottom of your notes. And we use scientific notation for a couple of reasons. When we have a number that is really big, really small, or when we have a number with lots of trailing zeros and we need to indicate that some of those zeros are significant, but not all of the zeros are significant. Okay? It uses the following form. We write numbers in the form of m times 10 to the n. M is going to be a number that's 1 or greater, but less than 10. And it can have a decimal point in it. And then n is going to be a whole number, so no decimals, but it will be either positive or negative. When we are putting a number into scientific notation, if you move the decimal point to the right to make it into scientific notation, then your exponent will be negative. So 0.0012 is going to be 1.2 times 10 to the negative 4. Okay, because you had to move that decimal point 4 spots to the right, so it's to the negative 4. If you move the decimal point to the left, then you're going to end up with a positive exponent. So 65,000 is going to be 6.5 times 10 to the 4th, because you moved that 4 spots to the left. And like I said, the other time that you might see us use this is if you have a number like 1,000 and you want to indicate to people that some of these zeros are significant but not all of them. So if you just have the number 1,000 like this and there's these zeros after it, none of those zeros count as significant because we don't know if they've been measured or not. Sometimes we'll use a period to indicate that yes, they are significant, so that decimal point means that all 3 of those are significant. But what if you measured to the hundreds spot, but you didn't measure to the 10 or the ones, and you want to indicate to people that that first 0 is significant, but you didn't measure the other 2 and you don't know? Well, we can't put a decimal point here in our number because that would change the value of our number. So instead, we can put it into scientific notation and say 1.0 times 10 to the 3rd. And by including that 0 after the decimal point there, we indicate that that 0 is significant. Because if you have a non-zero digit before the decimal, zeros after that become significant. But then you don't include the other 2 zeros, so people know, oh, those ones are not significant. They did not measure those. Okay. And if I wanted to indicate that the first 2 were, then I could, of course, put 1.00. And that would also indicate, hey, those first 2 zeros, those are significant. Next, we're going to talk about steps for solving a problem. Okay, the first thing you're going to want to do is gather the list of information that was given to you and identify what you are trying to solve for. So I just did this with my physics students. It's an incredibly helpful tool to go through the problem and say, what information do they ask me to solve for, and what information did they give me? So if you're solving a problem and they say solve for the velocity, you're going to want to dig through and see if you can in fact find a displacement and a time in that question. Then comes step 2, where you're coming up with a plan. You're going to draw yourself some kind of diagram to visualize the problem. Might not always be applicable to draw a diagram, but sometimes it's very helpful to draw something out to help you see what you're solving for. And then identify any equations, conversion factors, or chemical principles needed to solve this. Okay, so if you are solving for velocity, then you're going to need an equation for velocity. If your numbers are not all in the same units, you're going to need to convert. Got to figure out, what do I need in order to correctly do this problem? Then you're going to actually solve. So you're going to go through the steps of converting all your quantities to the same units, putting your data or your numbers then into those equations that you find, canceling out units that are being canceled by your calculations, and then, of course, rounding to the correct number of significant figures. And your last step is going to be to check your work. Go through it. Ask yourself these questions. Are my units correct? So if they ask me to solve for distance, do I have a unit that works for distance? Did I use the correct conversion factors? if you have the correct units, that's an indication that you did. If you come up with the incorrect units, then this is a way to check. Did I get the incorrect units because I used a wrong conversion factor? Because that can happen. You can use simple rounded numbers to make yourself an estimate and see if it comes close to your answer. So if you're multiplying 2,783 by 78, then do 2,000 times 80 and see if it comes in the same ballpark as what you did. Check the order of magnitude. Does it make sense for the question? If you're measuring the length of your desk in centimeters, you shouldn't have an answer that's in the 100,000s, right? So check, does this order of magnitude make sense for the quantity that I'm solving? And then finally, in real world terms, does my answer check out? If you were doing a density problem and you calculated that oil had a density that turned out to be greater than water, you would know you had to have made some kind of mistake in there because oil floats on water. It's not more dense than water. So something must be wrong. When we watched the video, they converted from miles per hour to light years per second. And it made sense that that number would be very, 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 very small because you're traveling a fraction, right, of a light year in a second. I know it seems like a lot of work to go through each of these steps, right? Analyze, plan, execute, and then check. But it's going to help you catch yourself from making simple mistakes, or sometimes big mistakes too, if you take the time to go through this. Now, I'm not saying that every time I give you a problem where you have to add more than one number together that you need to go through all of these steps. You know when you do and don't need to use stuff like this. But if you're working a word problem that involves calculations and conversions, it's a good idea to check yourself through these steps because you're going to wind up making fewer mistakes. The last thing we're going to talk about is just proportional relationships. Sometimes when you change one variable in an equation, it's going to affect another variable, and that can happen in one of two ways. Either directly proportional, so when you increase one variable, it causes the other variable to also increase, or an inversely proportional relationship where increasing one variable is going to cause the other variable to decrease. These relationships can give us some information about the numbers we're calculating, so it's just always good to look out for them.